Oh, look what we got here. Who did not calculate on wire gauges? A bit of voltage drop. A lot of voltage drop. Those are not even lighted up. And those are lighted up. Look at those LEDs. That's bad. There's a mirror LEDs. In here is nice. Those are properly calculated. But not those. That was awful LEDs. Yes, those panels are done. Not completely, but it runs. You can see there, the LEDs are turned on. Let's have a high voltage fuse. Is that what? The LEDs are turned on. Those are time relays. And that's the LED. The light for that the UPS is okay. We got two more lights on the top that needs to be connected in. That's for this panel is energized, or the other one is for the other panel is energized. And on top, cable harness again, looks extremely awful. Those are not connected yet. Those goes to that panel, connector board, CB connector board right there. One for the variac, one for the three-phase. Let's have a look on the back side of this. You can see the wire connections here for the LEDs and some more monitoring outside this room, on different places in this apartment. Two microcontrollers, one big USB controller here, 5 volt regulator, switch mode regulator, 12 volt power supply here, which I need to increase the voltage on. You saw on that LEDs, looks extremely awful. Inverter here, computer here, Optiplex 755, cable harness. What do we more with here? It's back side of this panel. There's some connector blocks, 24 volt power supply for those batteries, what they're called, backup batteries, some relays, MCBs, more connector blocks, mains incoming here, 3-phase, and some more connector blocks on the top. Let's close this panel and let's go over to the other panel, because there's some interesting stuff there as well. There's the back side of it. You can see the UPS contactors. And there we have a new gadget over there. That is a reactor coil for that variac. So we're going to have a closer look on that later. Yes, UPS relays, we got a transformer, RCDs, MCBs, some contactors on top, some bus bars, mains incoming over there, some controlling, and outputs. And all the way into the cabinet, you got an extremely messy looking thing. Look at that. Look at that messy wiring over there. Now I have a wooden chicken stick. There's some phase controller relays here that actually monitors if one phase has gone or something. Here's the mains incoming here. There's a CTs for a power meter and a kilovolt amp reactive meter. I will show you them. So 3 turns per CT. Incoming here, outcoming here goes the panel, and that's the cable which goes to the power meters. Incoming here, and that one goes to panel. Of course it's metal, so it needs to be earthed. And up here, common neutral on top. Here's a wire neutral that goes to the panel. So it's very important to keep that intact. And there's a phase wires to phase monitoring from the relays. And here are the power meters. We got a kilowatt here, kilovolt amp reactive, hertz, and an amp meter for the UPS voltage coming from the inverters. A little board that is not connected anywhere. And here are some switches to relays. It actually operates those sockets on top. And this one is for a light. Yeah, so it's light and everything. That's good. Disconnect it. Yes, relays and stuff. That's working. If I have a little bit of load, not much. We want more kilowatts. We don't want that. Not kilovolt amp reactive. If I have a lot of kilovolt amp reactive, I need to compensate with some capacitors, because that will just blow fuses with no good reason at all. If I have that one and calculate it with this one, you get the apparent power, and if you have the apparent power, you can calculate it with the active power and get the power factor. When you have the power factor, you can calculate which capacitor you need to use to compensate away this kilovolt amp reactive, or inductor if it's a capacitive load. Just want to show you some new insulators. This one is soft. I think Verec Menec has one of these as well. Some small ones. Some longer standoffs on the back. These are all standoffs. And I've got a funny looking thing there. The light bulb on top. 2 kilowatt light bulb right there. And some more small insulators and a little insulator on the back. And maybe someone is interested to see how much power I consume. 102 watts for this panel here. 50 watts to the control panel of that one. And 75 watts to the computer and other UPS stuff. And down here we got this museum stuff on the top of that reactor coil. I have to find a better place for them. Old stuff. Here's the reactor coil itself. It weighs 30 kilograms. Lots of chokes in it. That's 12 chokes. 4 chokes for each phase. All in series, of course. Not all of that, I mean 4 of them. In 3 sections. There's a Verec itself. There's the wires I need to connect. This one is for input. These long ones. And those short ones goes to the Verec. Or these screw terminals. I don't know how much this Verec weighs. I think it weighs over 60 kilograms. It's extremely heavy. Huge beast. Lots of bloody iron in that. So I need to get that moving a little bit so I can connect those wires. We got one terminal here. We got another terminal. You can see it, but it's on back side of this, somewhere here. Don't be scared, it's not energized. And this one has it right there. Those two are easy, but not this one. I think these are 120 degrees from each other. So this one is here and this one is here. That means that this one is all the way on the back. I can't reach that. That will be a little bit of a project, just for connecting those wires. And there's not so much done on that connector board. Still the glove and the Perilex and the 24-pin connector is not connected yet. I need to connect that reactor coil to that Variac Maniac. Thanks for watching, that was almost everything.